I'm Marcus Enoch. I'm a professor of transport strategy at Loughborough University, and I'm here to talk to you about using Internet of Things. Just to say, being a professor of transport strategy, I'm interested in the long-term future of transport systems. I come from quite a traditional transport background, and I'm not really a sensor or even particularly a data expert. I'm a domain expert. I'm interested in what the transport problems are and how we fix them. I'm also a bit conscious that this presentation might come across as quite upbeat. I'm aware that there are issues with data, and I'm pleased we're going to see some discussion about that later. So as I see it, I tend to, in a simplistic way, I tend to think of the ideal transport system for both operators and passengers, freight providers, as being where the supply of transport matches the demand for transport in terms of passengers per vehicle, vehicles per unit infrastructure, and passengers per unit infrastructure. And this is at all times of day, throughout the week, in all locations, and for all journeys. And where you get problems is where you either have too much supply for the amount of demand, in which case you have all sorts of issues like you're wasting resources, basically. You're wasting people, you're wasting skills, you're wasting land, you're wasting money, all these kind of things. Either that, or if you have too much demand for the supply of transport at a particular time, particular location, then what you have is externalities like congestion, overcrowding, pollution, etc. So that's the simplistic thing of where I think transport providers want to get to, is this balance between supply and demand. But until quite recently, achieving this kind of balance all the time is really difficult. And that's because, partly because at least, collecting the necessary data is really expensive, sometimes well, nearly always quite time-consuming, and so it's simply too difficult to bother with. So because of this, all these new changes in new data and so on, this is starting to change. So I just wanted to give a couple of examples of projects I've been working on recently, where we're using Internet of Things. So this first one is called Counter. This is all about managing overcrowding on the rail network, and this because train operators don't actually know how many people are on a train or in a railway station at any particular time. And there's many benefits as to why you might want to know how many passengers are on your rail system. Basically to do with planning timetables and managing revenue and so on. And obviously if you have stations which are overcrowded, there's all sorts of problems that you get in terms of passengers feel uncomfortable and stressed. You have reduced service quality, poorer passenger satisfaction, negative customer experience, safety implications, and also if you have people taking longer and longer to get on and off trains, then you get delays, and that feeds into all the problems I've just mentioned. So this project has been done with an SME called BlockDocs, and they work out of Canary Wharf. They've developed sensors which are basically thermal image sensors and passive Wi-Fi sensors. They developed them to count people in buildings, and we decided we'd try and apply them in a railway station environment. So at the moment we've got a test. It's an Innovate UK project, and we've got a test on platform 2 at Shoreditch High Street Station, and we've got one sensor that counts people on and off the platform via the stairs, another sensor that counts people on and off the platform via the lift, and 29 other sensors which count volumetric flow along the platform. And the idea is that we're using these sensors to build up a profile. Sorry, so these are the sensors, this is what they look like. We build up a profile which gives the operator, the station manager, a kind of a dashboard. And the idea is that we use the data so that we use machine learning techniques that will predict what the occupancy of the platform will be in 15 minutes time or half an hour's time. Hopefully that will give the station managers time to kind of realise that the station is going to be overcrowded, and then they can introduce various interventions to stop overcrowding occurring and keep the number of people fairly nice on the platform, if that makes sense, to keep the station quality there. And the second project I wanted to mention, this has been done in Mauritius, I'm working with a guy at the University of Mauritius, and he's an Internet of Things expert. He's very interested in all kinds of different types of very cheap sensors. What we've done so far is we've equipped 10 buses with a kind of a communications module. And the communications module is nothing special apart from it's very cheap. The idea is that we have this sensor that can use GPS to track where the vehicle is exactly on particular routes. And then it communicates that information back to the control center, and then it sends that information out to passengers so they have real-time passenger information. So that's not particularly new. But what is new is that then we're developing a whole range of sensors, a whole range of modules that will then add on to this communications unit, and therefore we're kind of just generating lots and lots of data in terms of exactly when the doors open and when they close, in terms of infrared beams to get on and off the bus, so you can count people there, seat sensors on every seat so you can work out seat occupancy, the whole series of sensors about the climate within the bus and the movement of the bus, so you can look at comfort. We're connecting it into the ticket machine data. We're connecting it into the engine data, connecting it into various cameras so you can look at CCTV. And we're just basically producing these, the idea is that we build a kind of a fully instrumented bus that'll be, the cost of building all these sensors and stuff will be less than $1,000 a bus. And then the idea is that you send all this information back and so on. I meant to bring an example of the initial module, but it's, I have to confess I forgot. So, okay, so that's bus controls. And overall, what I think this means for the transport system is that historically we've had this kind of operating model which draws on very limited historic snapshot data. It's very top-down, it's very long-term, it's basically based on a planning paradigm, if you like. And what this leads to in public transport anyway is large single-purpose vehicles operating on fixed schedules, fixed route, and checkpoint-to-checkpoint services. And this type of public transport has basically been operating fundamentally the same for the last 200 years. What's happening now, or what potentially could happen now, if you have these really well-equipped vehicles, systems with data, is that you then move to an active management kind of model. And that means because you can pull on this continuous comprehensive data, and that leads you to a more bottom-up immediate planning kind of paradigm. And that allows you then to send out smaller vehicles that are multi-purpose, so if there's not enough passenger demand, you can send them out carrying parcels or some other form, something else to do. And they can be demand responsive, flexibly routed, point-to-point, more passenger-focused. So that is kind of most of it. I just briefly, if I can, just go back to this one. One thing I wanted to mention about this is that we're also integrating the data we get from these sensors with a whole range of data that you can get available from the rail industry. So there's data called Quartz, which is basically the rail sector on several lines now collects second-by-second information about when the trains are kind of moving into a station and when they leave. So you can look at delays, you can look at dwell times at railway stations. The service we're also looking at also has data on train weight data. So that is a kind of a proxy really for managing, for looking at passenger demand on the actual train. So we're pulling that in. We're also pulling in data from weather sensors from the Met Office and so on. So you can kind of build up quite powerful sort of types of data and integrate them with your sensors. And just a final point, on the thing about, in the last presentation was interesting about this idea that we don't want lots of ad hoc data being generated and stuff. Part of me, I can sympathise with that, but part of me also feels that maybe that's not the way that things are going. The whole data sort of landscape, for me as a non-expert, seems to be going is very fragmented, And there is all this data, and in a sense we can't control that, so we should maybe just try and embrace it and just, you know, pull as much of the data as you need together, because producing it is now so much cheaper and easier.